Yeah? Because the one thing that we ended on was a little bit of a state of confusion as to why we couldn't generate the our program generator. When we wanted to generate an IO server for, this is of course on my AB train, which you will also follow after a while. We wanted to, if you remember, we wanted to create a IO server for PROM IP7. That was where we sort of left off.
Yep.
And when I tried to generate it, it came up with this message that says, it didn't come up with this message. This one says that it already exists, therefore it cannot generate. All right, let me just go and train, and then I will go and I will delete the module from that IO server, and I will delete, where's the source? I will delete the source because that was generated before. So now we can get back to where we were. If I try now, I get this message, which now is back to where we were. Primary key not found. Do you remember that?
Yes.
At the end of our last session, right? So I then got myself into a state of confusion, but I resolved it shortly afterwards, after a good night's sleep, and cleared my head a bit. The situation is this. That file, as we saw, did not have a key. And so I, with your agreement, agreed that that was the first key and that was going to be the second key that would make it unique.
Yep.
Then we took an F3 to save and exit. And then I took another F3 to save and exit. And then I did a recreate. Now this should have recreated the file. But if you remember, the key structure showed white, which indicated that AO had keys defined, but the file had recreated without keys. Are we up to date?
Yes, but I think I know why.
Now that's interesting. You tell me.
If you go there, it's still in access path arrival.
Thank you. That's what I found out the following morning. You need to change this. Now, I had a discussion with Marinus because it occurred to me that, you see, once you make it unique, you can't change it away from being unique because it's got keys. If you want to make it non-unique again, you have to take the keys off. And I thought to myself, why don't I just make that totally automatic? But there are reasons why you may want to have a physical file without keys. And one of them is that it could be a simple work file or a transaction file that you're writing out and reading back in again, and you don't need any keys. You're just going to write it out sequentially and read it back sequentially. So we left it alone. But you were right, Bernard. Once you change that to unique, and then you recreate the file, this time if you do the cross-check, you can see the key structure matches.
Mm-hmm.
It's not blue, it shows up here as green, and we can then get back here.
But Tommy, what could be automatic is whenever you put a unique key, when you go back to the previous panel, it could, it could change automatically to unique.
That is, except you may not want it to be unique.
Even though even though there's a key, but on the other panel, it's automatic. You put a key and it's going to put unique on the top of the screen.
No, you're right. There is something I could do in there. I don't like to force people to do something where there's a situation where it may not be required, but I will look at that for the next release because it is a little bit of a nuisance. But having put that key on, I'm now going to create the service program, the standard service program, which, remember, I'm doing this in ABC Train, and of course you will be doing it shortly too. There we have it. It's filled itself up properly again, and now that I hit generate, it will actually generate it. And we can see from there, and I must just get this other pic. Now, this is where I get so many different screens, and I've got to try and find out where I am. So please forgive me. Showing table, right. There is the two modules so far that we have. We then have the binder source, which exports those two symbols, and then we have the compiler, which includes the two modules, and we have all our export parameters, and we include the service program that we use. Okay, so those are the elements that we're going to use to make the service program. Now, this is a module. It has the module's name there, which is the file name followed by $, and the word export, which makes it an exportable procedure, i.e., in terms of a service program, it's callable because you are exporting its symbol. So all we need to do is we need to take this program and compile it, which has now happened. And then I can then run it, which I've got a little, I do a little thing here. I don't know whether you guys have used these user actions in ILE. Do you? Set up your own commands.
You mean in RDI, Tom?
And not ILE, RDI. Sorry, you're quite correct. RDI. Yeah.
Joel and Francis.
Yeah. You can set up your own commands here. This list of commands can be set up, and you can do all sorts of strange things with it. I have 3 at the top here. The first one is to change the library to current. So I can change the current library to ABC Train. Then I go back, and I will call that program, which will cause it to compile. And there you can see down there, it says it's compiled successfully. Then I simply go back again, and I reset, clear the current library. That makes sure that this value and that value put this thing into the right program, into the right schema. That's what those 3 little steps do. I suppose I could at some point in time have got lazy enough to combine all 3 into a single CL and run them all together, but I haven't bothered. So that will have created the service program, which, if we look at it, You will now see that there is a star program for CLLE, which is the actual compiler itself that was compiled. We have a module here, which is the odd dollar. We have I need oh dear. Why is this not? You know, I hate it when these things which are supposed to just be that simple don't. Sorry, I'm puzzled. Because this should show me a service program. Why didn't it? Okay, well, let's just do the normal debug. Work BJ, star ALL. What did we call it? PROIRS. There's the one, but there's no service program. So the service program never ran. That can be the only conclusion from that, which the compiler never ran, which is puzzling me. Let me just see, there's odd. I suspect I know why. I'm just changing the library list and putting ABC train in the library list. You see, the compile actually failed. No module found specified for the specified value from IP7 And that, of course, was because of my silliness. I did not compile. Although I generated it, I did not compile it. And that's the reason for that. So now, having to go through all of this exercise all over again, there we are. That's what it should have looked like. There's the two modules. But the service program still did not compile, which is very annoying. Maybe because I didn't compile it properly. User action, change current library, user action, or no, it didn't compile again. Why not?
You know, Tommy, our error handling is ERR, not ERH.
Yes, I know, but remember, I'm working in my library, not yours.
That's
so
okay.
I have to stick with the ERH. Service program, that one's not created. Binder language compilation failed with 3 errors and 1 warning. And if you look here, you see ABC train, source iOS that, export block not completed, end of file found, syntax error, syntax error. My goodness gracious me. The binder source is not behaving itself. If you look at these messages, Find a language, 3 errors and 1 warning. You see this here? Which I was showing you how to make a comment, if you remember. We are going to try it again. Call it. Now it's created the service program. And now we simply just return it to its clear current library, and we can now go back here and do an F5, and we now have our service program, which is there. Sorry for the delay, but these are little bugs that once you get the hang of it, and of course I'm working with bits and pieces. Once you get the hang of it, they come very, very easily because it's the same routine every single time. I've got a service program, I've got 2 modules, and of course I've got the 2 data files, both of which are now being served through the service program. Just as a matter of interest, if you ever want to look and see what a particular service program is handling, sorry, I'm just going to get my face off here because it tends to distract me, and I'm sure it distracts you too. If you do a 5 against a service program, it displays all the service program information, including the current export signature, where its source is, where its export member is, everything like that. All sorts of information about this service program. Once you get to that point, you will notice this is the detail is basic there. If I hit Enter key, the detail changes to size. This is the size of the service program. Current number of modules, current number of service programs. Now, interestingly enough, you're seeing there's 5 there. 5 service programs, whereas on the compile, I only made 1. I only added 1, which was the error handler. So that's the size. String directory gives you all this information, most of which I have no idea what it means or no idea what to do with it. But here, when the detail changes to module, you get a list of the modules that make up this service program. The next page is the service programs that are used by this service program. I'll say that again. This is a list of service programs that this service program uses. And you'll see the first one here is the error handler that I put into the compiler. But the 4 others all start with a Q. These are service programs that the compiler uses to generate and drive a service program. These are part of the operating system, and those 4 will be included on virtually every, well, they will be included on every single service program you ever compile. Okay, the next thing here is it shows you the exports, the procedure exports. Which procedures are exported from this service program. And remember, it doesn't have to be all the procedures. It just has to be the ones that you want to be callable from elsewhere. So those are the export procedures. These are the data exports. If you are exporting any data elements, they will show up here. And then activation group exports, which I've never seen, I've never used, I don't know what they do. So I can't help you there. You'll have to look that up yourselves. Activation group imports. And there's the signature. So essentially, if I go back to here, this here is your export symbol table. Remember, we talk quite a lot about import symbol tables and export symbol tables. This here is this one and the next one are the export symbol tables for this service program, which you control by the binder source that you put into this, that you compile this with. So you can get all the information you need for that service program just by viewing it with a 5, which displays service program. Okay, that is the service program that is now available to use to do I/O on either of those 2 files or both of those 2 files. It's sitting in train and it's callable from any other program. There's 2 callable procedures. Okay, so let me squish that down and let me move on. To a summary. I put this in because after our last week's conversation, I thought it might be a good idea just to summarize this whole ILE program thing, because it can get very confusing. And once you are comfortable with it, it's easy. So let's see what I've got here. There are basically 2 types of ILE program, only 2. There is the callable programs, which is a star PGM. And then you have the other one, which are callable procedures, service program. Now, remember what I said quite a long time ago. ILE operates on procedures, bound or collected into modules and then bound into programs or service programs. So the lowest callable level in ILE is a procedure. And in fact, it's common to other programs too. I think C+ and all those, they also have callable procedures. Let's have a look. This callable program can contain multiple procedures within modules. So it can contain numerous procedures contained in numerous different modules. It's not one procedure or X procedures in one module. It can be multiple modules containing multiple procedures. Strangely enough, the service programs can contain multiple procedures in multiple modules, exactly and identically the same. So at this point, you can bundle modules together with procedures to make either of these 2 types of programs. Let's look at a procedure. Local file specs, optional for a procedure. Local data definitions, optional in a procedure. Procedure code, rather mandatory for a procedure, because if we didn't have code, there wouldn't be a procedure. Now, a procedure acts very much like a mini program. It has an entry point and it has an exit point. And if it exits, it can exit normally or with an error condition. Either of those 2 is valid for each procedure. Let's see, there's another procedure I've just done. And in fact, I've said procedure times n here. These, you can have 100 procedures in a module, or you can have 10 procedures in 10 modules, or however you want to organize it. The only thing I have to say in terms of that is, please organize it logically. Group your procedures within modules that make sense. If you look at the error handler that you have already been playing with, you will see there are 5 modules, and I think there are about 30 or something procedures that are regrouped. How and why did I create 5 modules instead of just 1 module? The answer to that is quite simple. The certain procedures like the send and receive, send error messages, send diagnostic messages, all that group uses the same APIs. So all the procedures that used one or two particular APIs were grouped in one module. Just makes the organization a lot easier. Please do it logically. If you're not certain, throw all your procedures into one module and leave it at that. But it helps if you break this thing down, because the whole idea of modern RPG code is to reduce the complexity and create simpler blocks of code that are easier to write, to test, etc. So yes, you can have as many procedures in a module as you like. Just be sensible about it. Right, what did I click? I didn't click anything. Here we go. A program contains only one callable entry point. That's all. And it's defined by using the control opt keyword main with a name of a procedure. Now, if you have multiple modules, only one of those modules can define an entry point. Only one. All the others have to have no entry points. Having done this, using this, an entry point would be defined to be the beginning of whichever procedure is named there. All other modules, if there are any, cannot have an entry point specified. So a program has one entry point only. A service program, each procedure can be a callable entry point. By using the export keyword on the procedure, you can create a callable entry point for that particular procedure. So every procedure becomes callable. You see, the structure's basically the same. It's the way the compiler puts this thing together. Oh, and this keyword control opt no main has got to appear on every module in a service program. This one appears on all modules except the named module in a program. So those two control options are pretty much appear in both types of program. Right, so we slap on a couple of global file specifications, which are optional. You don't have to have them. And global file data definitions, which are optional. Now, I want to clarify one thing here very carefully. When I use the word global, it is global within this module, i.e. whatever is specified up the top of a module here for these two items is available within from all procedures. It's not global throughout the program, and it's not global throughout the service program. It is global only within the module. So if I have 70 procedures, they all have access to the global data items and the global file specs. The local file specs and local data definitions are only available to its related procedure code. Okay. Now, if I use create RPG mod, I will turn this construct into a module. It will be the same whether I'm going to end up creating a program or a service program. This result is exactly the same. And don't forget something very, very important. And I hammer this because people, when they start working with service programs, they forget this very vital piece of construct, and it causes, if you don't remember it and you don't know what you're dealing with, it causes a lot of problems. Your IST, or import symbol table, and your EST, which is your export symbol table, are generated during the compile of the module. Okay, so import symbol tables are built from all requests within the code that are asking for symbols that cannot be resolved inside this module. An export symbol table is made up of all data, global data, and all procedures that carry the export keyword. So you have, what do I want and what do I have are the two lists that are always associated with every single module. Right, what happens next? To create the program type, the callable program, which, by the way, can only be called using a call, it's a dynamic call. It's using the call command. It's a dynamic call, it's not a bound call. As a result, it has a slightly higher overhead than the bound call. You can use either the create bound RPG. The create bound RPG is used when you have one module and multiple procedures, and you have defined a single entry point, and you use create bound RPG. And that's pretty much the norm that most of us create programs with. But if you've decided you want to break your program up into multiple modules, you then use the create program command, which allows you to compile multiple modules into a single program. People say to me, well, why do you want to do that? One of the reasons why it can be useful is if I have a block of code that is really common to a number of other programs, a group of programs, I may want to compile that block of code as a module and then compile it into 3 or 4 different programs. The problem with that is that if I change that common block of code, I have to recompile all of the programs. Whereas if I put that common block of code into a service program, I don't have to recompile anything when I change it. So there's the only advantage I can think of is that one. For a service program, you compile it using create service program. And it's the 2 compilers that actually generate 2 completely and totally different objects. One is a star PGM and one is a star service program. Remember, we also have, when we compile the service program, we need to nominate the binder source for reasons I've already explained. We want to keep our external symbol table for the service program in the same order. Otherwise, we get all sorts of strange. If you move a symbol around in a service program, you end up calling the wrong service programs because it's not done by name, it's done by location. And it's location in the export symbol table. Okay, so that's the summary. I hope it hasn't been too heavy, but it gives you all the bits and pieces. And I guess over time, you will, if you use it, become comfortable with it. Okay, any questions at this particular point in time before I do the next thing? Okay.
Okay.
Yep. All right. Then I came across I thought about something else. Oh my goodness, why is this all broken? I mentioned earlier in our conversations, I said, I think it was when you were asking me, Bernard, about SQL selects and joins, live joins inside a embedded SQL. I said, why don't you let DB2 do the heavy lifting and create a logical file?
Yes, I remember.
And I just wanted to highlight this because most people forget it. They get, I don't know what the word is. They get sequelized. IBM has been very remiss, as far as I'm concerned, in not pointing out one serious or significant thing when they've been plugging away at the SQL. Logical constructs that we have available to us on the IBM I are 6, not 3, and not 2. Most people see only the index and the view. They forget that there are the DDS logicals still available to use as you used to use them. And one of the things that's very interesting about this is that the only direct sort of relationship between a DDS logical and a DDL logical is index to BR index or binary radix index. Those are the only two that have any sort of common use. All the others are totally unique. For example, a lot of people think a join in DDS, a join in DDS is similar to a view in DDL. It's not. Because a join in DDS, you can give it a key and you can sequence the records. A view in SQL, you can't. There is no order by statement in the create view. So in order to sequence a view, you need to build a BR index on top of the view. So the join and the view are not equivalent. The multi-format join, and I think you use quite a few of those, Bernard, if I'm not mistaken, has no SQL equivalent. There's no SQL equivalent for a multi-format join. So don't ever forget that you've got 6, not 3 options when you're looking at building a logical construct around your database that can do an enormous amount of the heavy lifting. Okay. I'm not getting a quick, yes.
You may want to just explain a little bit more in terms of what happens, with your embedded SQL, what the operating system does, and why you would, from a performance perspective, prefer to do so, where your database engineer is in charge of what actually happens.
Okay. Simply put, when you embed SQL into an RPG program, the compiler is a different compiler, as you are well aware. It's got a different compiler, got a different name, got a different everything. And it embeds a lot of data structures and calls to external programs. I think we had this discussion last week as well. where, in fact, by embedding SQL, you are creating overhead in your RPG program, which if you created a logical construct and just processed that in a normal way, you wouldn't have. Look, I could have this discussion. We won't call it an argument. I've had this discussion with numerous people. Which is faster, SQL, RLA, SQL, RLA. And everybody who's on the SQL bandwagon, SQL is always faster. And if you're on my side of the fence, SQL is not always faster. So building logicals, particularly where you have a performance requirement like interactive jobs, where the overhead of building an index every time you want to find a record becomes a little heavy. You can make it faster by pre-building that index using any one of these 6 options, and then just simply reading the record that you want, and that record, one record, pick it out, contains all the information that you need, even if it's across 16 or 20 physical files. By the way, I think the maximum limit of physical files in a view or join logical at the moment, if I'm not mistaken, is 64. Anybody who joins 64 physical files into a single logical view needs to be taken out onto the patio and shot. Okay. As I say, these things are all possible, but they should definitely be done in moderation. You can't go crazy. Now, there's one question of, yes.
Sorry, what is the measure? When will you decide when to create a permanent structure, or when will you use the select?
Okay, I'm getting
embedded SQL.
I'm getting patience, please. The question I've been expecting, and I haven't got yet, is what is this? Whoops. Anybody know?
Nope.
It's a thing called an encoded vector index. Now, you probably don't know because you can't define it in a program. You can't query it. You can't read it. You can't write to it. In fact, you can apparently do nothing with it. What it is used for, it's a special type of index that you can create and will be used by your SQL statements, your embedded SQL statements, to speed up the process of creating your open data paths. It will sort of, if you get it right, it will sort of help you out with the performance issues that you get around SQL. So the next question, of course, I always get is, how do you get it right? This is the one I like. Now, I've just got to remember how I did this. Yes, I do remember. We go here. And we go here. I'm going to show you something that you probably didn't know you had. And I can't get it to work on your machine. I've tried. So you're going to have to look into it a little deeper. But I'm going to go to my session here, which is the session that I've got that you're looking at on the screen. And I'm going to click the Actions button. And I'm going to choose Schemas off the Actions button. And now it's come up on the other screen, so I'm going to have to move it across here. And that is what you see. I open that, and I open Schemas. Now, obviously what you would see at this point in time. Can you read that, or is it too small?
No, it's okay.
Is it? Because I don't think I can make it any bigger. I'm going to pick a schema that I know what I'm doing with. It's the test environment schema that we're using all the time. And I'm going to right click on it. And there's an entry here called Index Advisor. In the background, and this is one of the reasons why SQL has a performance overhead, whether you like it or not, is that all the time that you are using SQL, it's analyzing the open data paths that it is building. It keeps building open data paths and it analyzes them. And if it comes to the conclusion that you could do better, it issues an advice, an index advice. And when I click it, this is the index advice that comes up for my machine, my test environment. Interesting. What?
You have a lot.
Huh?
You have a lot of advice.
Yep, I do. And the interesting part about this is there's a huge amount of information here. There's a huge amount of information. The interesting part is you go to the top of this list, without filtering it or doing anything about it, you go to the top of this list and you can see that entry. It is a file, AOF 130F, which we use a lot in AO. It gives you the schema that it's in, etc., and it gives you an advised key. It's giving you an advised key. And it's advising that you create an index of BR, i.e. an index, a binary radix index. And last advised for query use 19th of the 9th, 2024. And it's been advised that, look at this, 36,737 times. I.e., when one of my applications uses SQL to do row selection, it's finding that there's a delay caused by the fact that there's no index. Because remember one thing about SQL. SQL uses whatever logical access paths it can find. When you say select X from so-and-so where this equals that, the where this equals that, SQL goes searching for an existing logical that is sequenced in that manner so it can pick a block. And if it can't find the logical that it can use, it builds its own access path and it will then issue an advice to say, I've had to build my own access path because I did not find one that I could use. The interesting part about this is it says it's a row selection. That's why I'd advise. I'm telling you what key you should use on a BR index, a binary radix index. And the rows in the table when advised was 12,881. And you get a bit more information down this side. MTI, I used to remember what MTI is, but I can't remember. Maybe you can look it up in the background. And first advised for query use was 24th of the 8th, 2021. That's probably the last time I changed that file for any reason whatsoever. So, but you can see how useful this could be. If you look for the next one down, you can see 14,000 advices. It's also looking for a binary radix. Most of these are BR indexes. you go down to the bottom, there's a lot. They're all BRs. You will often get an EV, encoded vector index, showing up here as the advised index. You can see reasons advised, row selection and ordering grouping. You can get a lot of interesting information. And if you build your logical constructs using this tool as a guideline, you can actually improve the performance not only of your database and getting DB2 to do some of the heavy lifting for you by building logical constructs that give you benefit. You speed up any SQL you want to use. So, any questions?
You didn't tell how to get it right, the EV index. Because
I didn't tell you how to create the EV index. Oh, that's very easy. Didn't I tell you? Oh dear, oh dear, oh dear. Trust me, Bernard.
Because the EV index is in the background. You cannot tell, I'm going to use it that, but no, if it's there, the system will use it.
SQL uses it. Okay. How do you create an EV index? Okay, let's create an EV index in ABC train. You see, I can create, let's do it on PROD ord. You see, PRODORD A or naught. Let's keep it at naught. That's a logical, whatever. You see here, too, I've given you a way of creating an EV index in AR. It's actually very simple. Put it in that library. You pick the file that you're building it on. And actually, it looks exactly the same as another index. It looks exactly the same as an index.
Okay, Tommy, I've shared the link with everybody.
Ah, good. Thank you.
Okay.
MTI, whatever.
Yep.
So
it stands for Maintained Temporary Index.
Ah, that's
which is the operating system.
I knew it had a meaning. What it is that SQL builds a temporary index, and it maintains it for as long as it can while you're using it. And when you know these things, you will understand why, in fact, using SQL has an overhead, because SQL is doing an incredible amount of work in the background. If you can remove some of that overhead, you can make your performance better. So an EV index is, in fact, exactly the same as a BR index. There's no difference. None. Does that answer your question, Bernard?
Yeah. Yeah. I'm currently looking at this file in index recommendation. And I have a few. That could be beneficial.
Did you find what I was looking for? What happened? Did you find your index advisor on your system?
Yes. Yeah,
wonderful.
I'm looking at it right now.
Wonderful.
And there's a recommendation which is, strangely enough, by status. There's probably a status field within that file prodor.
Yeah.
And I have it recommendation 9,500 times, which is probably a good, yeah.
Just be a little careful. Once again, with toys like this, people tend, and I'm not saying you will, because you're a very level-headed individual, I think anyway. People tend to get overexcited and carried away about this. Be careful what you do, because you can overdo it. I always start at the top and look at the number of times that it's been advised. Over what period has it been advised? And how many records are contained in the file that's being advised? All of these, look at this one here. This one has got 224,506 records in it. What file is it? It's a 390. I don't even know what 390 is. But you can see it's been advised 41 times. And it's got a lot of records. There's another one, half a million records, over 500,000 records. That's 170. That is the field definitions within each file. And obviously, there are places where I look for field reference and dictionary reference. And it's advising me to do a binary radix index 50 times. That one is worth looking at. The ones up the top here with the most advisors are, of course, indicating the most usages. You need to be very careful that you just don't go ballistic and create an index for every single entry in this table, because doing that will not help you too much.
But I can tell you, Tommy, that I have a few that are over 400,000 times over files with plus or minus 100,000 record.
Those are well worth looking at.
Yes, I think so.
Those are well worth looking at, because they might, you see, the big question here is, how much is it going to help the performance? This is a question I always ask myself. Is the effort worth the benefit? And it's very difficult to tell. I tend to build my systems without worrying too much about performance until somebody brings a performance issue to me. But it's also very nice if you can improve the performance for people. They never notice. They just moan like hell when it slows down. You make it faster and faster and faster, they don't say a word. You slow it down a bit, and brother, they get upset. But you have to balance this. You can't go crazy. I tend to recommend, and this is something I can back this up with no documentation at all. I tend to recommend a physical to logical file ratio, average physical to logical file ratio of 1 to between 6 and 7, or 6 and 8. i.e., on average, you should have between 6 and 8 logicals for each physical in your database. Yeah. It indicates to me that your database is doing a lot of work for you. If it's lower than that, and I've had 1 to 2, 1 to 1 even. In fact, one particular case, I had 1 to 0.64, which means there were fewer logicals and physicals in the database. And when I see something like that, I say immediately your programs are overworking. You're doing too many IOs inside the program. You don't have a high enough physical to logical ratio. Okay, so that is my heavy lifting part 1. Do as much of it in the database as you can, because the more you do in the database, the less your program has to do. And that's where the hard work costs money. Okay, let's go on to this. This you've seen before. This is our IO server module. And remember, you can bind numerous modules together to create a service program to serve a group of physical files. But now we come to probably what is my most favorite topic of all of the topics in this course. And that is this one. The triggers. This falls into the category of DB2 heavy lifting number 2. There are 3 heavy lifting numbers. This is definitely number 2. What have we got? Oh, we finished already, hey? Top was 4. Okay, we started an hour late. I'll give you that. Right. The heavy lifting part 2 or number 2 is definitely the triggers. And the triggers here are extremely powerful. You need to become very happy and use triggers everywhere that you can, because not only will they offload CPU cycles from your application code, but they will also build a consistency around your database where everything it will become more and more consistent, because you're using the same code to do the same thing all the time. So let me just do this, and you see the question mark coming up. Up until now, before we get involved in triggers, any questions?
No, so far so good.
So far so good. So you will now go and build a service program for those 2 files in ABC Train. Will you do that for me?
We did that, Joel. We did that.
Yes, it's already done.
It's done.
Yes.
Wonderful. I'm going to ask you a question and see how well you answer this one, Joel. Is it tested?
Nope.
No.
It compiles with less work.
You do need to test these, but you're going to have to test them in some way. Let's wait until we get to the triggers, and then you can test them all together, because you want to be able to debug through this whole thing, and you want to understand line by line what everything is doing and why, because only then can you really own the whole concept of it. Right. Next, my favorites. Have you guys got good imaginations? Because construction of triggers requires not only understanding and not only skill, but it requires imagination. And it requires thinking out of the box. And this statement, which is supposedly comes from Albert Einstein, if you always do what you always did, you will always get what you always got. And there's nothing truer than that when we're talking about what we're talking about now. You've got to start thinking a little bit, it always says outside the box. You must think, you must ignore the box. You must eliminate the box. You've got no limits to what you're doing. Right, let's have a look. Let's have a look. This could take us the rest of the way, and then some. You've seen this piece of it, I'm sure. There's your relational database management system, which is called, hopefully, when you get it all together, by I/O servers, and only one I/O server per table. And the RDBMS communicates with the table. Right, so when the RDBMS gets a request from a client, a lot of people think that when you read, write, insert, update, delete, you're actually communicating with the table itself, or you're not. You're talking to the management system, the database management system, and it is working on your behalf. So when the table has a file definition table, contains trigger definitions, the RDBMS says, oops, I have a trigger. defined for this database file, and I will place a call. First, are there any before triggers defined? And secondly, are there any after triggers defined? Of course, you can have both, one or the other, or neither. There's a third, we call these times, trigger times. There's a third one, which is an instead of trigger. Now, I won't use this because it is a SQL trigger. It has to be written in SQL, and after about a week of trying to make this work for me, I gave it up and I thought, really, I don't want to fight with it. So I have never used an instead of trigger. This is used on joined SQL views. When you attempt to read or write, you can read or write to a SQL view, and instead of doing the read or the write, it calls this trigger. So if you want to investigate it, you're more than welcome. I wipe it out of my memory because I don't know, maybe I'm too old or just not ready for that yet. Right, let's have a look at the events. The before time, the before trigger, has 3 possible events: insert, delete, update. Those are the 3 things that you can do to a database table, and they can be intercepted by the before trigger, and the programs, one or more programs, can be connected to one or more of these events. Now, once again, just because you can doesn't mean you should. I can connect 3 programs to the insert event. I can connect 4 programs to the delete event, and I can connect another 4 programs to the update event. Why I would want to do that, I have no idea. Also complicates the issue, makes management and maintenance a problem. So my general rule is the before time is 1 program connected to either 2 or 3 of those events, depending on what you need. I have a trigger program before insert and the same program before update, and sometimes before delete as well, depending on what I'm doing. In some cases, I attach a trigger program to insert, delete, and update for other reasons. But really, I really have more than 1 trigger program on the before stack. Simply because too many IOs also complicate the issue, and they create complexities in management, etc., etc. As we get into more detail, I'll show you those. Right, let's have a look. If you have multiple trigger programs connected to one particular event, the sequence in which those trigger programs are called is called the ordinal number for an event. And it is determined by the order in which the trigger is added to the file. So if you have 3 programs attached to the same event, they will be executed one after the other in the order in which they were added to the file. Now, this is something you've got to be careful of if you're doing this, because you don't want triggers to potentially be executed in the wrong order. Now, the AO's naming conventions makes this impossible, and I will show you that later. Okay, that's how, and also if you only have 1 trigger program attached to all 3 events, then you're not going to have a problem like that anyway. Let's have a look at the after. let's have a look at, what you can do in the before trigger environment. Now, I'm going to give you a list of a few ideas, but here is where you must throw away the box and really decide what you want to build into the trigger programs, because the more you build into your trigger programs, the less you have to worry about what's in your application. And remembering that the trigger programs are running at the priority of the database management system, i.e. trigger programs and their associated code run at the highest priority available on the system, which means they have the highest performance of any program you can write anywhere. Right, data validation. The primary task of a before trigger is to make sure that the data that is being manipulated inside that table is valid in all senses of the word, that it has, that its values are correct, its relationships are correct, everything is correct. Validate the data. That's the one thing that a before trigger must do. And the more completely you can do that, the more integrity you're building into your database. Program access check. I have a little subroutine, well, a little procedure that I use to check. I go into the call stack. I have a look at the call stack and I see which program called this trigger, which program actually initiated the event. And if the program is not an IO server, I will reject the attempt at update. You may think that's a bit heavy-handed. It means that nobody, under any circumstances, including a user with all object authority, can touch my database except through the use of an IO server. I.e., by doing this, anybody who's got a SQL client, they try and change the data, it just gets kicked straight back at them. And not using an IO server, they can't change the database. Okay, you can use that one whether you like it or not. The other one is default provision. You can change values or put in defaults or calculate things, i.e., if your client is doing an insert, they provide you with a record. Some of those fields may not be filled in, like, for example, the current user. I'm sure your database files all have insert date timestamp, last user, or insert user, changed date timestamp. Am I right? Yep. Pretty much. Your avatar nods when you do, hey, Bernard. I can see it.
I know.
These things can be put in there by the trigger. If it's an insert, the trigger can insert the create user and the create date timestamp. Even if the client puts his own one in, the trigger can overwrite it. In an update, the trigger can insert the update the user and the update date timestamp, last update date timestamp. So your application doesn't need to do that. I can put in defaults where there's a blank. If you want yes, no, and the default is no, and the client doesn't put in anything, you can put the default of no in there. These are things you can do to provide defaults for various fields in the record. It's very powerful, and of course offloads a lot of work from your application and makes the provision of defaults consistent throughout the entire use of that table. So that's another one. Now, relationship checking. I can, in a trigger program, I can check relationships between files. It's something sometimes you need. There are other ways, and we will talk about the constraints coming up now. There are other ways of doing relationship checking, which in the database, but you can say, okay, you're trying to insert this record in this file. Does this particular record in another file have a value of XYZ? If it doesn't, I can't do this. So relationship checking allows you to go beyond the typical relationship constraints, the relative record constraints. And it allows you to do much more complex relational checking if you want to do that. And now the next thing is, of course, etc., etc., etc. You can do anything that you want in a before trigger program, remembering that the record has not yet been inserted into the database table. It is still sitting in the client's record buffer. It has not been inserted in the table. Therefore, you can check, change, manipulate, or do whatever you like to that record before it even gets to the database. A very, very powerful situation. Okay. Once your trigger program has decided that everything is okay. First of all, if the trigger program decides, it's not going to happen, the trigger program will simply return an escape message. I'll show you the mechanics later. It will return an escape message to the RDBMS. And RDBMS will say, sorry, Mr. Client, I can't do this because the trigger won't allow it. Please rethink and resubmit. If the trigger is happy, the trigger will return to the RDBMS without an error message. At that point, the record is written into the table, and this is what makes IBM I unique in terms of database platforms. Once the before trigger has decided that all is well with the record, it physically writes the record into the table in the database. It writes it there, and it marks it as uncommitted, but it is physically in the table. Finds a place for it and puts it in, and it also then writes the journal entry for that update, insert, or delete. And this is why you have to use journaling if you're using commitment control, because the journal is a record of what has been done to the table, and the journal is what is used to reverse it out of the table if a rollback is required. And that is unique. All other database management systems, they hold the records in a buffer until a commit is issued. And then they write the records into the various different files. And a rollback, they just delete the buffer. But IBM's logic says there are more good updates than bad updates. Therefore, we will update anyway. If we have to roll it back, we roll it back. But they are less frequent and less demanding on resources. So that is the upside down way that IBM I does it. Okay, any questions on the before trigger? No.
That's okay.
Right, let's look at the after trigger. Insert, delete, update, and read. Or events. The first three, insert, delete, and update, behave very much in the same way as the before three, except, of course, the record is already in the table. So you can't change the record's contents. You can still tell the RDBMS that this is messed up. I don't want it. And RDBMS will roll it back. Not sensible, because it does create certain serious problems. The after trigger is designed to allow you to do things to the rest of the database once a record has been accepted into this table. And they can include data synchronization, i.e., this record goes into this table, therefore I've got to add this value from this record into another table. Or I've got to then summarize this record and synchronize it with another file. Summary maintenance, update, insert, or delete values in the monthly summary files. I know you've got these. Job submission. You've added a record to this table. That triggers a submission of a job to a job queue, which means it can run something in the background because of the fact that that record arrived in that file or was updated in that file. Certain things can be submitted to happen in the background. Audit data collection, often used, where now you know that the record has been accepted in the table. You can say, all right, audit data, I need to know when it was done, who did it, and what was changed. And I need to write that away to another file so that at the end of the year, at the end of the month, I can produce a report of 16 million pages, which I give to the auditors, and they can then take a year to go through it and find out what's not wrong with it. You know what I mean? I'm sure you understand what I mean. Read suppression. This is something that people don't particularly know about. After read calls a program. Now, this trigger program gets an image of the record and can have a look at this image, and it can have a look at the user, and it can look up an authority table or a role table or some other sort of authorizations. And it can decide that this record is not allowed to be viewed. So somebody's tried to read a record, and that person can't read this record because they don't have the authority to do so. I can return an escape message and cancel the read, so the person will not see that record. I've done this with SQL, where SQL says, select me 100 records with these parameters. And people come to me and say, why are I not asked for 100 records that I only get 15? Because you're not allowed to look at the others, because you don't have the authority to do so. The other thing that this trigger program can do is, in fact, to blank out certain fields and return the record with certain fields empty. Useful?
Yes, I think so. But this is after trigger, so is it gonna?
It's an after trigger. The record has gone into the database. It's perfectly okay. Remember, it's an after read. There's no before read. This is an after read. So if somebody does a read, that's what kicks in. You can't get an update and a read simultaneously. So it's only when a read occurs on the database that this trigger program gets kicked in and can decide whether that caller is entitled to the record or not. Yeah. And then, of course, that wonderful, etc., 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 which sits at the bottom. And this is where I said your imagination can go as crazy as you like.
Tom,
everything, yeah.
It might be a very good idea to provide an example specifically, and I think the example with regards to aid status, I think is always a very, very good one, because it just allows the aids.
Oh yes. Okay, that was well where I came across this read suppression thing. I used to work for a company called MediCredit, and they were a facilitator, yes, for medical claims. I don't know whether you have something similar in Canada, where you would take a script to a pharmacy, for example, and the pharmacist would type it into an application. It would go through to a central database for review and check and validation, and come back and tell the pharmacist, yes, this is okay, etc., etc. Okay. Now, a lot of those scripts and that medical information that was flowing backwards and forwards was sensitive because of problems like AIDS or other chronic diseases that people may have. And not always certain people that had access to the data were allowed to see these particular AIDS-related or certain condition-related information, because you do not want to compromise the people suffering from a particular condition. And that was where I used it. I had a look at the role, the level of the person who was trying to read the data. Because remember, the trigger program can get the user ID quite simply. And if that person wasn't authorized to that level of information, then I would simply return an escape message to say, no, you can't have this record. And that was very powerful. I suspect
I have a question. Yeah. Could it be done within, we are using Excel with the ODBC connection, for example, and we select data from, employee master file.
Yeah.
That we have a social number within. Then in the case that we upload the data,
yeah,
could we use the after trigger just to blank the social number, for example?
Yes.
Okay.
Because your Excel spreadsheet is using ODBC to read that table.
Mm-hmm.
So it is just a client.
Yeah.
And the point is, your after read trigger would then suppress, based on parameters in your database, would suppress the read on certain records, or take out fields in a record before it returns the record.
Okay, then it could be a kind of using the read after trigger in the case that we have sensitive information like a social number or a telephone number or personal information for the for the employee. Okay, thank you. I understand.
So it's something that not many people are aware of with these triggers, but it can be very useful, and it can once again take a load off your application, because if you connect something like that to a after read trigger, it's applicable across the board, all clients, all applications, regardless. It can be a SQL request, it can be an Excel ODBC request, it can be an IO server request. It doesn't matter where it comes from. If you don't fit the parameters, you can return the necessary information or eliminate the return information. So, as I say, I've used it in that one particular instance, worked brilliantly. I haven't used it since, so you're going to have to play with it a little bit to get it to work for you, but it's there and it works. Okay, right. Let's just have a look at another number before we get on with the next little game. Look at that thing at the top there. A maximum of 300 trigger programs are allowed per table. Again, I'm going to say the same thing. Just because you can does not mean you should.
We have a maximum of 99, Tommy. In our naming convention, we have only 2 digits.
That's fine. But my naming convention also has 2 digits. But remember, my naming convention says BI00, BI01, BI02. So it's 99 times 3 times 7. Okay.
Is it 200 for both of them or together?
It's 300 as a total.
Yeah.
300 as a total. Quite honestly, if you ever get even close to that, once again, out on the patio.
Yeah.
because the management of this is so difficult if you start going crazy. Rather build more function into the trigger. Remember, a trigger program can be made up of many procedures in many different modules. So you can build function into the trigger program in procedurized, modularized groups. So you can make one trigger program that does an awful lot. Or you could have a trigger program calling service programs, service procedures. So there's a lot of ways of doing it without going to the 300. I think this maximum of 300 is laughable, actually. No. All right. Now, how on earth does this trigger program or this trigger program know what is happening down here with this table? How does it know? I've said to you, we can wipe out values in records. You can use the default provision to put defaults into fields. How is that possible? Now, it's done through the trigger parameter list. And this is one of those things. I've been working with triggers since the middle 90s. And in all that time, IBM has never changed this trigger parameter list. Not once has any change been made to this trigger parameter list. Every single trigger program, whether it be before, after, or any of the events, they all receive exactly the same parameters. They receive 2 parameters. The first parameter they receive is called PI, well, PP, or whatever you choose to call it. It is an input parameter for the program. You'll see how it fits in. This is just a screen grab of the list. The second parameter tells you how long the first parameter is, which is not useful at all because I've never had to use it. So this is the construction. What I do is I usually create a PP, which is a pointer, and it is initialized as the address of PI. So this PI is based on PP. I'll show you the full code when we get there. The first 3 things that you have in the parameter list, remember this parameter list goes to every trigger program regardless, is the file name, the library name, and the member name, i.e. what is the file library member that is impacted by this trigger, by this call. It then has the event, insert, update, delete, and possibly read, and the time is a before or after. So it tells you what it is and what event has triggered the call. Commitment lock tells you whether in fact the record is currently under commitment control lock. That's reserved. This is the CCS ID of the file. And this is the relative record number. Come here. Relative record number of the file, of the record in the file. Sorry, forgive me. This is the relative record number of the record in the file. I've never had to use it, but sometimes I can imagine it could be needed. Then there's reserved. Right, now people will say, okay, but how can the same parameter list be passed to every trigger program for every file? Because files have different records of different lengths. How can the same parameter be passed regardless? And this is how it's done. There's a fixed portion of the parameter list, which is what you're looking at here. And there's a variable portion of this parameter list that follows after this that you can't define. Or you can. What you get is you get two records from the RDBMS, depending on the event. You get an old record and a new record if it's an update. You get a new record if it's an insert. You don't get an old record. And if it's a delete, you get the old record and no new record, because it makes sense, I am quite sure. What you get here is you get a value which is the offset to the start of the old record, the length of the old record, the offset to the old record's null byte map, and the old record's null byte map length. Now, if the offset is 0, there is no old record, but you can already tell that from the event. Updates and deletes have old records, inserts don't. The offset is a number, and this is why we talked about pointers earlier, if you remember. I have a pointer called PP. This parameter is based on PP. So my base pointer is PP. This is the offset from the start of the fixed portion of this parameter list to the beginning of the old record, like old record structure, i.e., it's somewhere down in this vague empty space that can only be addressed by a pointer plus offset. So by adding the old offset to PP, I get a pointer to the old record. Similarly here, I get the same set for the new record. I get the new offset, the new length, the new null byte map offset, and the new null byte map length. Now, that means that if it's an update, I will get both a new offset and an old offset. I'll have both. I'll also have an old and a new length, which should be the same. I can think of no reason why it would be different, but they do it anyway. And this is how I can find the records and return the records to the database management system because they're using a pointer. So the offset, when I add it to my PP, which is my parameter pointer, I'm looking at a record that actually is in the RDBMS. I'm not looking at a record in the trigger. I'm looking at a record that's in the RDBMS. You remember the session we had about pointers?
Yep.
This is the reason I put that session up front. Right. Null byte maps. Any ideas?
No.
No. Not surprised. Because null values is a SQL concept, really. It's never been a RLA concept to have a null in a field. Now, when the trigger passes you the when the RDBMS passes you the record, it does not pass null value. It doesn't pass null fields. It can't pass null fields. So it will pass the full field length, say character 5, which will be filled with blanks, or numeric 10, which will be filled with zeros. Even though the record on the database has a null value in it, it still passes the actual value to the trigger program, the default value, with the full record length. It does that, of course, because it doesn't want the record length to behave like a concertina when there is or there isn't null bytes. But the null byte maps indicate which fields are null in the database. i.e., if you look at the offset to the null byte map, you will find that if the record has 20 fields in it, there will be 20 indicators in the null byte map. It'll be a 0 or a 1. So you can use this to actually look at it and say, does my actual record on the file have a null in it, or is it a value of blank? You also, in the trigger, have the ability to change the null byte map. So if you've got a field that you want to make null in the before trigger, because it hasn't got anything in it, you can switch on the null byte indicator and it will go back into the database as a null field. So that is what the null byte maps are. And I expect if you feel inclined to use them, a little bit of probably research or an email may be useful.
Okay.
But they can be very useful, particularly if you have records with null capable fields in them. Do you use nulls a lot?
Oh.
Not. They are a default in SQL, actually. If you create a file in SQL, it's a default to have a null default value. Okay, so that is the parameter list that you get for every single trigger program. So it's a consistent, standardized parameter list, and it tells you everything about what the trigger is getting and what needs to be turned back. If, for example, you get an insert and you want to change values in it, you simply just go to add the new offset to PP. There's your record. You change the values in the record, and RDBMS gets the changed record. What are the mechanics around this whole thing? How does the trigger programs communicate with its client in such a way that everybody knows what's going on? How does the trigger program tell its client that it should go ahead with the update, it shouldn't go ahead with the update, what is wrong with the update? It needs to communicate. And this is where all the ducks finally line up in a row. IO server is a procedure. ILE is a procedure-based environment. And every procedure in the ILE environment has a message queue. I've said that before. There's the message queue for an IO server. IO server requests RDBMS. RDBMS, of course, has a PAG with a file definition table and an open data path. It has a journal if the table is being journaled, which it should be. And the RDBMS will then call a triggered program. Whether this be a before or an after doesn't really matter. The mechanics are the same. The only difference is that if it's a before trigger, the record's not yet in the table. If it's an after trigger, the record is already in the table, and you must bear that in mind. What happens when a triggered program discovers an anomaly? What happens? It calls an error handler. Lo and behold, we come to the error handlers at last. And it says to the error handler, I use 10 because that's send a diagnostic message. And I want to send this message informing my client that I have found something wrong with what he's trying to do. So it picks up the diagnostic message and sends it to the RDBMS, who immediately forwards it to the RDBMS's caller. That happens quite automatically. When you are validating records, you must check for as many errors as possible before issuing the final not going to happen message, escape message, so that the client at least has a good idea of all the problems that there are and doesn't have. Have you ever had an application where you do something wrong, it says that's wrong, and you fix that, and it says, yeah, this is wrong, and you fix that, and it says this is wrong? Ever had something like that? Yeah. It's very annoying. So the requirement for before triggers is that you identify as many errors as you possibly can. Once you have done that, you call error handler 11, which is to send the escape message. Because now the escape message is going to tell RDBMS no update is going to happen. I'm escaping this because the trigger program is not satisfied that this update can go ahead. So what will happen there is that goes there and that goes there. But now the IO server has received an escape message. Notice the trigger's closed down. It will have. It sent an escape message. Remember, a program that sends an escape message ends completely. The escape message is equivalent to set on LR return. It's the same thing. IO server has received an escape message. It monitors that escape message, and it passes. First of all, it calls error handler 03, which moves the diagnostics and then resends the escape message. So the diagnostic gets moved and then the escape message gets moved. That means the IO server will end as well, because the IO server has just sent an escape message. So the client has received an escape message with a whole series possibly of preceding diagnostic messages saying what is wrong with the transaction. The client can pass those on to the person sitting at the keyboard or can deal with them in any way at all. But the mechanism that the trigger performs is now complete and awaits the next call. Does that make sense? Are you comfortable with that? Because here's a pretty picture just to help settle your mind.
Do we need to know that the escape message is coming from a before or after triggers, or it's
It doesn't really matter. RDBMS handles it exactly the same way.
Because in the way that we do, before trigger is we want to do a validation and we want to know the escape message will return. Then we need to advise that, oh, okay, for this condition, cannot do any update. I mean that I need to know that the escape message is coming from before instead of the after. Can we manage the escape message then?
You remember your escape message is a predefined message.
Mm-hmm.
Okay. So you can define different messages for the before and after escapes.
Okay.
So yes, there is a way of identifying it. I use very few after triggers in what I do, because I'm not working with an ERP system, so I find less need for after triggers than before triggers. But in an ERP system, I would imagine you use after triggers quite a lot as well. Your client can tell by the type of message you send back. Yes.
Okay.
There is a error handler. I think it's your ERR04, which retrieves the last escape message sent, the number of the last escape message. So you could have the prefix, a predefined message has got 3 letters in the front.
Okay.
You could have TRA and TRB, for example, after triggers and before triggers, something like that. They're coming from a different source, a different origin. So yes, you can send them very much as you design them as you want. And obviously you want your client who is trying to do this behavior to know exactly what's happened, where it's come from. Yes. Has the record been updated? I hear what you're saying. Is it an after trigger? In which case the record is okay.
Mm-hmm.
If it's a before trigger, the record isn't okay.
Yeah.
Typically, when you get a escape message from an after trigger, the first thing that the client should do is roll back.
Yeah.
Because it means there's a record in the database and something's gone wrong afterwards. You should roll that back. Again, it depends how you code your client.
Mm-hmm.
But remembering that there's a lot less effort in the client programming because a lot of it is being done by the triggers.
We don't use, at this time, we don't use before trigger. We use mainly after triggers.
Okay.
It's because we didn't have yet that training, and we didn't want to jump into it at this time.
Okay. By the time I'm finished with you, the only thing you'll want to do is before triggers. That's a promise. I have, and I understand exactly where you're going with this thing. You don't want to jump into before triggers because you could break your entire application.
Exactly.
Because you have a trigger on a file and your programs are not designed to manage the trigger errors coming back.
Exactly.
I have a technique, which I've got a PowerPoint for it. Once I finish this exercise with the trigger coding and everything else, I will actually drag it out and I will go through that with you probably next time because we're running out of time. And I'll give you a technique where you can start to build before triggers without damaging your database in any way or your application in any way. And that eases you into the use of before triggers. And in fact, logs errors that the triggers are finding without crashing the application. So you can actually begin to see that the trigger is finding errors that your application is not trapping. Follow me. So I will go through that with you because it's obvious that you're going to need that. Otherwise, you're going to have to change every single application all at once when you put a trigger on a file.
Yeah.
And that is quite a frightening thought, I would imagine.
Yes.
I know. Been there, done that.
Yep.
Jean and Joan, you've got the same beard. You know that? And I can't even find a moustache, really. Okay. I think that's it for today. Took a little bit longer to get into this triggers than I thought. What we will do is we will look at some actual trigger code and examples and look at the trigger generators and what they produce and how. And then what I will also do is I will then use that PowerPoint that I've got to show you how to build triggers without risking your application, because that is important. I have to agree. Okay. Any questions before we close?
Yes, one last question. We how to use the we will see later how to call the IO server within the program, or because we've got IO server, but I don't know how to call it.
Okay. All right. I'll show, next week I'll show you a program. Actually, I'll tell you what I'll do. I'll send you a program that tests. You've got it already. The error handler. There's a test program in the error handler code I sent you, which shows you how to define and call an error handler. But I'll send you another example as well.
We have that.
Okay. Yeah. But I'll send you another example of how you use an IO server.
Yeah. And I think Neil can help us out on testing the IO server. Yeah.
Yes. How's that, Neil?
Yes, I can help. There's an example in the small application I gave you too, because
that's right. Yeah. So you can actually test it and see that it works.
Okay.
And I would suggest that when you do, fire up the RDI debug and actually step it through. I find it very useful just to understand code that somebody else has given me, to actually run it through the debug and step it one line at a time and read each line and see exactly what it's doing and what the program is doing and what the values in the fields are. It actually helps understand the basic code. That's my style. Might be good for you too.
Yeah.
Okay, guys.
Hey.
I hope that was a good shot. And we will see you next week at 3:30.
Okay. Next week, 3:30.
Eh?
It's 3:30 your time.
My time, of course, yes.
Yeah. Okay.
It should have been 2:30, but then you went and switched the clock on me. All right, guys. Enjoy your day.
Thank you very much.
And we'll talk next week.
Okay. Thank you very much, Tommy.
Thank you.
Wonderful.
Have a nice day.
Bye.
Thanks.
Bye-bye.
Bye.
Bye.
That was better, wasn't it?
Much.
Let me